Welcome to our first module. In this lesson, we're going to look at one way of interpreting data, namely interquartile range. So we're going to have a look at what that is and how we can use it. So before we look at interquartile range, we're going to just step back for a moment and look at where we've come with data so far in the previous years of maths. So far we've looked at measures of center, and this is our median, mean, and mode. They're looking at where the middle of our data is, and then the measures of spread. So far we've looked at range. Interquartile range, which we're looking at today, is another measure of spread. We're going to look at it, why it's a bit better in certain situations. So first of all, we have an example question. So we have some numbers and the range of these ones is 8. If we graph them, we can see they're reasonably evenly spread over that range of 8. So in this case, range makes a bit of sense. But if we go to this question, you can see it's exactly the same as before, except now we have this 20 added on. And that has a big effect on our range. Our range changes from 8 to 19, so more than doubles. And even though all of our data is really situated over here, because we have one outlier up here, our range becomes very big. So our measure of spread then becomes not as useful in describing our data, which is where the interquartile range comes in. So we're going to look at what quartiles are and then look at the interquartile range. So what we're going to do, quartiles are really just a way of breaking our data into 4 equal parts. So we start by finding where the middle of our data is, and the middle we know is called our median. So we can find that pretty easily. Next, we need to look at the first half of the data, but the part not including the median. So we've got this part is our first part of the data, and then our quartile, our first quartile, is the median of that first half. So we forget about all this data here, and we're looking for the median in this section, and we get the 2. So we now can call that the first quartile, and then this one here is our median. To get, if we move along, we call the median of our second part of the data our quartile 3. And the reason we can do that is because we have our quartile 1, quartile 2, and quartile 3. So these quartiles are splitting the data into 4 equal or almost equal sections. You can note here that just because of the number of values we have a reasonably rare situation. We have 4 pieces of data and then 3 here. But we've split the data into some equal parts. Now, it's important to know the other way of talking about these. You can call them quartile 1, 2, and 3, or you can call them lower quartile, median, and upper quartile. Now, if we move on, we can see that our interquartile range is going to be us taking the quartile 3 and subtracting quartile 1 from it. So we take this one and we subtract this one. So the upper median and the median of the lower group, and we're going to get the interquartile range. So in this case, it's 9 minus 2, which is 7. Now, if we go back to range and the problem we had with it, in this case, we've got a range of 19. When really most of the values have this range of 8 here. So we can tell they're reasonably close together, except for that one outlier. If we go with the interquartile range, we're going to get 7, which is much closer to that original range of 8, and you can see that the outlier hasn't affected it as much. So interquartile range is really a way of dealing with outliers. Now we're going to have a practice and try to find the interquartile range of this data. So first we need to find our median, or our quartile 2. And to do that, we just can knock off values as we go. So we knock off each side, keep going, and we end up with these 2. So our median would be 4, the average of the 2 middle ones. But we're just going to draw it as actually in between these 2 so that we can get the 2 sides, the 2 sections being equal. So we go on, we look at the first section, and then we have the second section, and we find the median in both of them. So that's just the middle number. So that's quartile 1 here, and our quartile 3 will be here. So now we've got our quartiles, and we can find our interquartile range. We do that by subtracting quartile 3 minus quartile 1, which is going to give us 1. Now you can see here, because of this massive outlier, if we had gone for the range, our range would have been 237. So it's a lot suggesting that our data is really spread out and there's not much grouping of it. But when we use the interquartile range, we can see that our data is actually reasonably close together, or the majority of our data is. Okay, now it's your turn. Find the interquartile range of this data. Okay, so we begin by finding our median, or our quartile 2, which is going to be 7. Again, we do that by just crossing off each pair as we go until we get to the median, or 7. So we've got the median. Now we look at the first half of the data, and this time it's going to be in between the 2 and the 5. So quartile 1 is going to be 2 plus 5 divided by 2. So the average of these two numbers, just like if we're finding median, and we get 3.5. Now we need to find quartile 3. So we're looking at this section. The middle of that is going to be this one. And we find the average of the 9 and the 14, which is going to give us 11.5. So now we've found quartile 1 and quartile 3. We can find the interquartile range. So interquartile range is going to be the third minus the first quartiles, which is going to come down to 8. Okay, if you have any questions, please make sure you do contact me with them. Otherwise, please continue with the work that you can find on Canvas. Thanks.